Let's look at some examples of applying the power rule. Recall that the power rule says that the antiderivative of x to the n is going to be x to the n plus 1 divided by n plus 1 plus c. So first, a straightforward example. The antiderivative of x to the 34th is going to be x to the 35th, add 1 to the exponent, and then divide by the new exponent. And don't forget to add the plus c. Now where things get a little bit trickier is when your exponents are negative or when they're fractions. So for example, if we wanted the antiderivative of 1 over x to the 5th, then we might begin by rewriting this as x to the negative 5. And then we need to add 1 to the exponent. Negative 5 plus 1 is negative 4. And then we divide by the new exponent. If we want to clean that up a little bit, that looks like negative 1 over 4x to the 4th. Now the same rule applies when I have fractional exponents. So for example, if I wanted the antiderivative of x to the 5/7, then I still have to add 1 to the exponent. We might want to do a little scratch work. 5/7 plus 1 is the same as 5/7 plus 7/7, which is 12/7. So my new exponent is 12/7, and then I have to divide by the new exponent. But of course, dividing by 12/7 is the same as multiplying by 7/12. So an easier way to think about what happens with the coefficient here is after you add 1 to the exponent, you multiply by the reciprocal of the exponent. So let's practice that again. If I wanted the antiderivative of x to the negative 2/3, then I have to add 1 to the exponent. Negative 2/3 plus 1 is negative 2/3 plus 3/3, which is 1/3. So my new exponent is 1/3. And then I multiply by the reciprocal in front, which will be a 3. Now remember with radical notation, if I have the qth root of x to the p, that can also be written as x to the p over q. So if we wanted to find, for example, the antiderivative of the square root of x, we could rewrite this as x to the 1/2 and then add 1 to the exponent. A half plus 1 is 3/2. Multiply by the reciprocal in front. And again, remember the plus c.